Hi ladies and gents. So I'm going to make this video for you to give you a little bit better direct instruction because I was looking over some of the solutions from last week and there's definitely a lot of confusion on these problems. So let's kind of slow it down, do a little bit more direct work and work you through these. All right, so here is the worksheet for today and I want to go through everything from the start. So whether the other video wasn't as clear, I'll give you everything step by step. All right, so here's number one. So if you look at number one, well, basically, as we go through this, we're going to go through the list: holes, vertical asymptotes, and horizontal asymptotes. So we'll see if these have all of those or if not. So the first thing I look for is actually vertical asymptotes. So vertical asymptotes come from your denominator. So literally your denominator is x minus 1. So if you take that denominator and you set it equal to 0, I have it right here, x minus 1 equals 0. And if you solve that, I can add 1 over to both sides. If I add 1, it cancels, it brings it over, so you get x equals 1. That's your vertical asymptote. All right, so later on that could look like something different, but that's your vertical for now. All right, next thing I look for is horizontal asymptote. Now horizontal asymptote comes from this word up top here. All right, I've got horizontal asymptote, so let me just highlight this. So it looks funny, it looks like some graffiti up here, but Bobo Botten eats DC. Right, that's the phrase that's going to really help you with this. So Bobo stands for if your exponents are bigger on the bottom, you have 0. So y equals 0 is your horizontal asymptote. Bigger on top, you have none. That's Botten. So bigger on top, there is no horizontal asymptote. And eats DC, this last thing, if the exponents are the same, then you divide coefficients. I put divide coefficients down here to remind you. So these are the little memory tricks to figure out horizontal asymptotes. Right? So going down with this problem for number one, if you look at the whole problem, look at the fraction first, look for exponents. What I mean by exponents are exponents of the x's. So if I go back to the exponents here, where the exponent down below is going to be x to the first, if you look up top, there is no x. Really, we could consider that an x to the 0, so I'll just put this in. It's not really there, but technically there is a 0. So look at your exponents of the x. Right? So if the exponents of the x are bigger on the bottom, just the x's, bigger on the bottom, you have 0. So y equals 0 looks to be your horizontal asymptote, but it's 0 for this, but we have to add the 2. That's why your horizontal is y equals 2. So Bobo helps us out here. Bigger on the bottom, you've got 0, but any coefficient at the end, you have to add 2 to that. So if you add a 3 there, add a 3, add a 4, subtract a 5, whichever. So that number on the end is going to end up adding to your horizontal asymptote. So y equals 2. Right? So vertical, we've got x equals 1. Horizontal, we have y equals 2. And you'll see this thing, it says no holes. Well, a hole, from up here, right? A hole is when you have x's or factors or a binomial or something that cancels out. In our original problem, we have nothing that cancels. Just for example, I wrote one down here on the left side. If you had y equals 3x over x, well, these x's would be able to cancel. That's going to create a hole in your graph. So the x's would cancel. So if you set x equal to 0, which I have here, that would be your hole. You would have a hole at x equals 0. But in this problem, there's nothing that cancels, so it's considered no holes. All right, so really at that point, you have to match up your answer choice and see which one's going to give you x equals 1, y equals 2, and no holes. So let's take a look. So in here, x equals 5 halves, definitely not 1, so it's not that one. Looking for x equals 1. Nope, negative 1 will not work for choice B. C looks good. We've got x equals 1. Oh, no holes like we had before. And the y equals 2. And just to go through your graph, right, vertical asymptote means x equals 1 right here. Right, so that is your vertical asymptote. It's going to show you what values really do not exist there. The horizontal asymptote is a horizontal line through 2. And really to create the rest of these branches, you'd have to plug in numbers using your graphing calculator and find out what your branches look like. You'd have 2 of these. But really, the horizontal and vertical asymptotes give away the graph. And later on, we'll show you what those holes are. Actually, just to look over here, here's a hole right here. And that's just a bad value. All right, so let's take a look at another one. And I want to show you one that's more complicated, one that has some factoring involved. All right, so let's see. If I did one, let's take a look at number 5. All right, so number 5 is definitely more complicated. These were like the ones you had last week, which may have been a little bit too tough, but I'll work you through this one as well. So before we even talk about vertical asymptotes, horizontal asymptotes, holes, we need to break this down and factor these. So let me change my pen over here. So when you factor the top, break it down with all those different factoring methods, but really you're going to see we have an x as a GCF, and what's left inside is going to be an x squared, right, minus 9. Sorry, my writing is a little bit horrible with this. And that's the top part. The bottom part, I see we have a 4 in common with all these. So I can take my 4 out as a GCF. And then what's left is going to be, let's see, x squared plus just an x. Got a better plus sign. And then minus 12. So always look for a GCF first, but you should be noticing something else. As I sit here and look at these, we have more factoring to do, right? So this is factorable. This is also factorable. So just for space sake, let me bring it over here, right? And I'm going to show you what these become. So the top becomes x, and this is a difference of squares on the top portion. So it's going to be x plus 3 and x minus 3. Right, so that's the top. Get my proper format here. So you want to break these down and factor as far as possible. That's why these are really pretty tough. All right, so you got the top. The bottom, the 4 comes along for the ride. That's your GCF. But do know that it's going to break down into 2 more binomials, and this is the original, like the old school factoring. So what numbers are going to multiply to give you negative 12 and add to give you 1? All right, so to multiply to give you negative 12, add for negative or positive 1. You're going to have x plus 4, if I can fit that in here. And then you're going to have x minus 3. Right, because 4 times negative 3 is going to give you negative 12, but 4 plus negative 3 is going to give you 1. So now this is completely factored. All right, so the one thing we're going to notice is, look, you have 2 x minus 3's. Since you're multiplying, these can be canceled, which I'll go right to it. If you have something that cancels, that is a hole. All right, so when you evaluate for a hole, you have to set that equal to 0, that whole factor, so x minus 3, right, and then solve it. So of course, by adding 3 over, you're going to get a hole at x equals 3. Okay, so that is the hole. I'll just put hole here. So not only did we find a hole, and I'll show you what that means on your graph, but we have to find the other portion, so your vertical asymptotes and your horizontal asymptotes. So vertical, again, if you look at just your denominator, and we're looking at just the x portion, it's really going to help us. So I see this x plus 4. And really the whole issue is if I plug a number in for x and get a 0 here, this whole thing is useless. It's division by 0. So we cannot have a number that gives you a 0. So what number, if I bring it over, x plus 4, what number is going to give me 0 if I add it to 4? Well, right, x plus 4 gives you 0. And whatever number, if I solve it, I would have to subtract that 4. And we're going to get x equals negative 4. Right, that's going to be my bad value. That will give me really an undefined number, so that's going to be my vertical asymptote. And it just goes by that denominator. So your denominator, find out what's going to make your denominator 0. The 4 really doesn't matter, but this whatever value gives you 0 when you add it to 4, which is negative 4 plus 4 would give you 0. That's your vertical asymptote. That's your bad value. Okay, so one more thing to look at. Okay? And typically you can do this from the original or from the factored version, either one. But look at your x powers, right? Just the powers to find out your horizontal asymptote. So if I go back to the original, you'll notice that the exponent is bigger on the top than it is on the bottom. Bigger on the top, right? Even if I look at your factored form, this is really x squared over x. It's still bigger on the top. And if we go back to that other note, if it's bigger on the top, this is button. So bigger on the top, you have no horizontal asymptote. So I'll just put none here. So then this is really all you need to go through and find out if your asymptotes are there or if you have holes. So I'll take a look at A since it's right here. Holes, x equals 3. Got that. Vertical asymptote is -4. That kind of fails. And the horizontal's off as well. So no good. Vertical asymptote for B. You've got -4. Nope. Holes, none. Nope. Doesn't solve that one. So let's go down further. And for a hole at x equals 3, oh, we got that here. Your vertical asymptote, x equals -4, which, scroll up a little bit, we did have, right? And then your horizontal asymptote is none. So there we go. That's choice C. So these are a little trickier because there is factoring involved, but that should walk you through each piece of this. All right, so the holes, the vertical asymptotes, and the horizontal asymptotes. All right, so guys, so this should be a little bit easier, a little bit more direct to follow. But you'll find out these top ones up here, if I look at, say, 3 and 4, these are a lot nicer. You can find your vertical asymptotes, remember, just from the bottom. What's going to make that a 0? Right? Your horizontal asymptote, Bobo button eats DC, so find out if your exponents are bigger on the top or bottom. Don't forget on this one, you'd have to add that 2 in there. And holes, honestly, nothing's going to cancel here, so there's no holes for these. So simpler ones typically have no holes, but the more complicated you will have to factor, then solve, but look for holes, vertical asymptotes, and horizontal asymptotes. All right, thanks guys. Hopefully this makes more sense.